Hello, welcome to OCC Math Seminar Lectures. Today's section, we're going to talk about probability. Right. So in this first slides here, I'm going to introduce you the basic concept of probability. Okay. So let's take a look at an example. I want to roll a six-sided dice. So the dice has six sides. So all the possible outcomes of the dice are six of them, right? So there's a first side, there's second, there's third, there's four, there's five, and there's six, right? Because there's six-sided dice, right? So you have six sides, six possible outcomes. Now later, I'm going to introduce to you all the possible outcomes. In statistics world, we call that sample space. But that's later. Sample space. Now, we'll come back to that later. Okay. Before you roll the dice, the dice, do you know which one will occur? No, right? No, you don't. Nope, you don't. What is the probability that the outcome will be a 4? 1 out of 6, right? Because there's 6 possible outcomes. The probability you can get a 4 out of 6 possible outcomes are 1 out of 6. Okay? So 1 out of 6. For this art studio part, you don't have to know. Usually in class, I show the code to students, so if they want to simulate it themselves. But all you have to know about this part is that here is the simulation of flipping coin. H and T's are represent head and tails of the coin. So assume we have a fair coin and we flip it. As I flip it many times, the probability I'm going to get a head and the probability I'm going to get a tail is roughly 50-50, right? So so here in the flipping coin example, the possible outcomes are 2, right? Head or tails. That's it, right? So that's all you have to take to get out of this part of the code. You need to know the code. Okay, there are a few ways to think about the probability. The first one, which is my least favorite, is called personal and subjective probability. So if I denote P of A, usually if you denote something some sort of probability of an event, they call P of something. So here we're going to call P of A. P of A is a probability in which that a given individual believes that the event A will happen. Right? So for example, this is football season. So say during the weekend you watch a football game with your buddy, and you turn over and ask him what is the probability of this team will win in this game, and he say maybe 70%, right? So that is the subjective probability or subjective guess. Usually it's not a long-term probability. I wouldn't say that. It's more like a personal educated guess at best. Okay, so it's not something that we're gonna go through too much in this section. Okay. For long-term relative frequencies, this apply for things like stocks, right? Where P of A, again, the probability of some event, right? A is event, P is mean probability, so P of A is probability of some event. Is the proportion or probability of times event A occurs if the random experiment is repeated many times. Like I said, think stocks, right? So for a long-term investment in stock, for long-term stocks, for example, big company like Google, Amazon, Apple, Tesla, etc. Those are called long-term stocks, right? Now, historically, over time, the stock grow, right? So over time, use likely to make profit if you invest in some long-term stocks, right? I'm not talking about Bitcoin or yeah, not that. That's too unpredictable. Well, anyway, so here is, let me put it down here like think stock. Now, for the third one is the one that we actually dive into this section. It's called one of the model is called the baskets model. So P of A, so probability of some event, is the proportion or the chance or probability of a marbles in a basket that have an event A on them. So let's take a look at the example next. So here I have a baskets model. Right? Inside the baskets, I have 10 marbles, 3 blue and 7 white. One marble will be selected at random. So you just put your hand in there, randomly pick one marble out. So what is the probability that I'm going to pick a blue marble in this basket? 3 out of 10, right? 3 out of 10. 3 out of 10. All right. So let me tell you, in this baskets model, the formula will be this: the probability of desired outcome is equal to the number of the desired outcome divided by the number of possible outcome. Oh, you have 10 marbles, so the 10 possible outcomes. Right. Oh, can't write properly. Outcomes. Okay. That's the number of desired outcomes is because the three blue marble there's that's my desired outcomes. And then the number of possible outcomes is 10, so 3 over 10. Let's fill in some statement. A probability statement is not a statement about fact. Remember, it's not a statement about fact. It is a statement about chance, right? Hence probability, right? It's about chance. It's all about chance. Right. All right. So let's think about this. You read online that the probability of being dealt a flush, meaning all 5 cards of the same suit in a 5-card poker hands, is 1 out of 508. Explain carefully what this means. In particular, explain why it does not mean that if you are dealt 508 5-card poker hands, one will be a flush. So maybe let's take a moment, pause my video, and think about this. Okay, so what does it mean when you dealt a 508 5-card poker hands? Now the number 1 over 508 means that when you dealt 5 cards poker hands, you are likely to get a flush, right? You're likely, but it doesn't mean that you will get one, right? So 1 over 508 means that, let me write it for you properly, so that when you dealt 508 5-card poker hands, it's likely that one will be a flush. Is likely. I'm going to emphasize lightly that one will be a flush. It doesn't mean that you're going to get one. Right? It's just lightly, it's just chance. Remember about the probability statement. It's all about chance, right? Not fact. All right, second example. Winning the ACC tournament. Winning the ACC tournament, the annual Atlantic Coast Conference men's basketball tournament, had temporarily taken Joe's mind off of the Cleveland Indians. He said to himself, I think that Louisville, pick one, has probability of 0.05 of winning. North Carolina's probability is twice Louisville, and Duke probability is 4 times Louisville's. I'm not insider, so I'm just gonna say Louisville. All right, what are Joe's personal probability for North Carolina and Duke? So if I write it in terms of in a statistical way, I'll write it like this. Probability you know as P, right? And inside parentheses is an event. So what they asking, the event that North Carolina and Duke will win, right? So probability of North Carolina, I'm just gonna say NC here, wins according to Joe's, personal probability is what? Well, North Carolina probability is twice Louisville's. So that means what? 0.05 times 2, right? So double, so it's equal to 0.1. And the probability that Duke winning, so Duke wins is Duke's probability is 4 times Louisville, 4 times Louisville. So 4 times 0.05, that means 0.2 or 0.2. What is Joe's personal probability that one of the 15 teams other than Louisville, North Carolina, and Duke will win the tournament? So everybody else, right? Well, this just complement now, right? Remember, the total probability is 1, right? 100%. Can't go over that, right? So probability of others will win. I'm going to say P of others win is just 1 minus the teams that we already know, right? So minus what? Minus Louisville, which is 0.05, North Carolina, which is 0.1, and Duke, which is 0.2. Use your calculator, you can do in your head. That would be 0.65. So 65%. You want to do 65%, you can. Same thing.